All right, so we're on to chapter 9. Just so you are aware, I have all the blank notes to chapter 9 put onto Google Classroom. So if you want to print them out, if you want to look at them beforehand, I have all the blank ones on Google Classroom again at the beginning of the chapter. And I'll still continue to do the YouTube videos. I will still continue to post the notes after they're done. I'm going to let you know though. This chapter 9, is probably one of the trickier ones that we'll be going into. Not because it's overly complicated, but because we're going to be using some new buttons on the calculators. If we're using those, we'll be going into the sine, cosine, and tangent. And also we'll be using square roots and then square roots and then squares. We'll use exponents as well. So this chapter is going to kind of go into a lot of that stuff. And because of that, it will be a little bit trickier.
Are the notes already posted on your classroom?
All the blank ones are on Classroom, yeah.
Okay, can I just take notes like later tonight? I don't have classes.
Yeah. Do you want me to print that off?
No, it's fine.
Okay. All right, so as I'm going to get started on this, you guys can I write that stuff down again? You'll be able to find geometric means between two numbers. That's the first part. Yes, sir? Chapter 9.
Chapter 8.
Yes.
Oh, sorry, this is 8. I lied and I wrote it wrong then. Hey, so I'm looking at that class. I apologize.
I just did.
So I think I wrote the wrong thing on Classroom as well.
Oh, yeah. Who is that?
Okay, so the reason we're going to go over this, and the reason we're spending so much time on triangles, has anyone figured it out yet? On why we're doing so much stuff with triangles as opposed to any other shape?
We use those the most.
Yeah, we use them the most. But like if I have a rectangle and I have no idea how to solve it, I can break that rectangle into two triangles. Okay, if I have a pentagon, pretend like it's a good drawing, I can break it up into smaller shapes. I got a triangle there, I've got a triangle there, and then I've got a rectangle. Again, I can break up pretty much all of my shapes into triangles. If I can figure out how to do triangles well, you can pretty much do every shape in geometry with the exception of circles. Okay? So that's why we focus so much on the triangles, because they are kind of that building block that we can almost turn any shape into. Okay? So anyways, that's the first part. We're going to be finding some geometric means. We're also going to be going into problem solving using parts of a right triangle, and then the altitude to figure that one out. So we'll be able to break one triangle into two smaller triangles and use those same proportions to be able to solve some stuff. All right. On to our very first new term for this chapter. You guys have heard mean before. What is the mean? So like normally whenever we have done the mean, it's been the average. You add two numbers together, divide by 2. Okay, so whenever we've done mean and average up until now, it's been adding 2 and then dividing by 2. The geometric mean. The geometric mean is going to be not completely different, but it's going to be different than that. Instead of adding two sides, the geometric mean is going to be side A, or line A, times B. And then we're going to do the square root of both of those. So the geometric mean will be multiplying two numbers and then taking the square root of that to find the geometric mean. So everything we've done so far has dealt with the arithmetic mean, so like addition ways. The geometric mean is going to be multiplying and then finding the square root. Okay. So that's kind of the simplified version of it. This concept where we go through, you don't have to worry about this whole entire thing. But the reason we can figure out, this is kind of a shortened version of this. The reason that this geometric mean works is we're still able to do those same cross products that we did this last chapter. Okay, and I'll zoom in, you don't have to write this part down, but I'll zoom in on it to try to explain it a little bit better. Okay, if we have, I'm going to kind of give you two triangles here. And then I've got a bigger triangle. Whoops, that was supposed to be straight. Okay, and we know this one. We know this one. We don't know this. We don't know this. We can figure it out by still doing those same proportions. We could still have like the hypotenuse over the other side is going to equal that other side, or sorry, the hypotenuse over kind of that other one. If we were to do the cross product to figure out, again, these ones match up, these ones match up. These are going to be the exact same value. If we ever have that same value there. That's how we're able to figure out the geometric mean. I have some better pictures of triangles as we go on farther. But realistically, this is what we've been doing. We're able to use the cross product to figure out what that geometric mean is. So without getting too crazy into it, I'm going to look at the first two examples and I'm going to have you guys do a couple. These ones are not too bad, but again, you have to use something besides one of these calculators. So for me to find the geometric mean in the very first one, I've got 5 and 45. I'm not going to try to set it up as a cross product unless you really, really wanted to. But to find the geometric mean, I'm going to take 5 times 45, which is going to give me, which is going to give me 225. To find the geometric mean, we need to take the square root of 225. So the geometric mean between 5 and 45 would just be 15. That makes sense in how I went through those steps? Again, multiply the two numbers together, and then we're going to take the square root. All right, so somebody talk me through step number 2, or the second example. I've got
12 times 15.
I've got 12 times 15. 12 times 15 is going to be
180.
perfect. So that equals 180. To get the geometric mean, I'm going to take the square root of 180.
Yeah.
You can give me a decimal for this stuff if you like. If you want to leave it as a mixed number, you can. But I got 180. So it should be 13.4. Or if you wanted to do something a little bit different, perfect. Yeah, I got 6. Square root of 5. I can take either one of those for my answer. Again, multiply the two numbers, take the square root of both of them. Question so far? You guys show me what you got.
God bless you. Allergy season, guys. Okay.
That was like wet.
That was a what?
Wet.
That was not wet.
That was disgusting.
It was quite the video. I apologize. I apologize for my allergies, Milo. Okay.
You should.
What'd you get? What'd you get? What'd you get? Nice.
Just
So, Hello? What'd you get? Scratch.
It's next week. It starts the next week.
For me.
Hello, really good.
Awesome. Awesome.
So
good.
I remember those processes are good snacks. I just don't remember good snacks.
Good.
You don't really get over this one.
Nice.
The answer 10.
It is.
Sorry.
Thursday.
One.
Good.
I don't know how to get that. You do.
Bro.
It is so easy.
Yep, I'll show you the steps.
Okay,
that's all I need to know, guys.
Probably,
Really, I think you're we're talking to you.
I was actually talking to myself.
Were you?
I myself, but easy now. Thank you for the.
All right, so to find the geometric mean, I take 2 times 50. I'm going to do the steps with you. I kind of walk through. I liked what I saw. I'm going to take 2 times 50, which gives me 100. To find the geometric mean, I'm going to take the square root of 100, which is 10. Geometric mean, how you feeling? Thumbs up, thumbs down. I love it. Okay. Here is where things are going to get trickier. Okay. Again, some of you guys have this part down. Some of you guys don't really have it yet. I want to make sure that I go through the similar triangles, the similarity statements that I've been kind of pushing on for quite a while. This is where they're going to be important. Okay, this is where understanding how those triangles are similar is going to make our lives easier, or it could make it a whole lot trickier. All right, so I've got this triangle. I've got A, B, C, D, and in this big triangle, the very top is a right angle. And if I have an altitude drawn straight down the center of it, okay, meaning that the bottom will be a 90-degree angle, I can break up this triangle into 2 smaller triangles. So that's kind of what this part is showing. I've got the big triangle ABC, and I can break it up into ACB, which is a smaller triangle, and then CDB, which is the other small triangle. Can you see where those 3 triangles are coming from?
Yeah.
Okay. I'm going to draw all 3 of them just to show the 3 parts as they'll go together. So I've got A, C, and then B. Up here is my 90-degree angle. I've got A, oops. A, D, and C right here. And then I've got C, D, and B. Okay, I've got 3 separate triangles that I can make from that same big one that went through here. Okay, it makes that right angle, it goes straight through. So all 3 of my triangles that I've created, all are going to have the exact same 90-degree angle that'll work with it. So I'm going to try to do some highlighting to show you what's going on here, hopefully. Okay, in these similar triangles, okay, in the similar triangles, I know that this side and, oops, wrong triangle. I know that A and C, this hypotenuse, so again, the one that's opposite, so this angle and this angle, because they're opposite of the hypotenuse, are going to be the same. Same thing with same thing on this hypotenuse over here. All three of those are going to have that kind of that same hypotenuse itself. Okay, I've got the kind of the long side underneath. Those ones all kind of match up. And then I've got these triangles that are all matching up as well. So again, I have similar triangles. I have 3 sets of similar triangles. Okay, and that's really what this whole entire thing was saying is once it got broken down and I could divide it into different chunks, I now have 3 sets of similar triangles between all of them. All right? So if I have 3 sets of similar triangles, I know that I could have it where it's this one, like if I were to give them numbers, so I'll say this would be like number, whoops. I'll say like this is number 1, 2, 3, 4, 5, 6, 7, 8, 9. If I just gave them all different sides, I know that angle 1 and angle 5 and then 7 would all be the same. Again, I'm just going through and I'm highlighting all the same blue ones together. Just like angle 2, 4, and 9 would all be the same ones. I could do the same fractions for all my green sides if I want, but I can set up all 3 of these separate triangles to make them similar to each other. That kind of makes sense? Again, I use the highlighters to try to show that. Because there's now 3 triangles in the mix, it makes it difficult. Yes, ma'am.
What number is under 5?
Were you talking here?
No.
Oh, sorry, that's a 4.
Okay.
And I can do the same thing with all the green ones too. I can say 3, 6, and 8 are all similar as well. But I mainly wanted to show that all of these ones we can put together and we can start to solve those same problems. Okay? So for the very first part, as we'll go through, we're going to start looking at similarity statements, which are the things that people loved. Sorry, anybody need more time with that stuff up top? Okay, I'm going to go down to the similarity statements. So just so you can visually see it, I'm going to show my 3 triangles here. Oops, I'll draw better. And I'm going to draw them all so that way they kind of have the same sides. I've got G, God bless you, H and E. Down here is my right triangle. So I did the big triangle. Next one I'm going to have is going to be E, H, and F. Whoops. E, H, F. And that's my next one. And then my last one will be F, H, and G. Okay, I made all 3 of these different triangles. I got the big triangle first, and I got the little one, and I got the other side. I'm going to let you know right now the easiest one to figure out whenever we have these triangles is when you have a right triangle, remember, you got a leg, and then you got the hypotenuse, right? You guys remember that? Hopefully. All right, so I've got a leg, and a hypotenuse. The easiest thing to figure out on these triangles is to figure out the hypotenuse. Hypotenuse is going to be opposite the right angle. So this angle and this angle and this angle will all match up. Okay? And then the other little part to see is the way the altitude cuts straight through it, is this angle F for the small triangle, if you were to rotate it down, it's gonna be the same angle as this. So for my little triangle, this is my little triangle here. This point up here will connect to the right angle, just like this point here will connect to the right angle. This point will connect to that right angle. So let me get my other highlighter to show that last part, or the next part. Bless you, I think. All right, so again, I've got F is going all the way to H. So the sharp point to that one, to this point, to this point. I now have two sides. I can guarantee my third one is going to be the side I don't have yet. Those ones will all match up as well. So I'll just get one more highlighter just to show that last piece. Whoops, that was the wrong highlighter. So I've got that side, I got that side, I got that side. So my similarity statement will be angle, or I'm going to say triangle, G, F, E. So that's my first one, G, F, E. So just so you can kind of visually see it, I started on my blue side, and I went to my purple. That's the order I went. Blue side over to purple, as long as I'm consistent. So G, F, E, blue side over to purple, so this will be F, H, E. So it's similar to F, H, E is similar to, again, blue side to purple, G, H, F. If you don't want to do the highlighter thing, and I'm fine with that, my suggestion is if you're going to draw these triangles to match up, showing the angles, and if that's what you'd like to do, by all means, go for it. You've got the right angles. Those ones are already marked. I know that this angle and this angle and this angle are all going to be the same. So again, start with your one arc, if that's the way you're going to do it, if you're not going to highlight. The one arc to the right angle, and then the missing one. But that's where you're trying to figure out how you can go in order. Either highlight, great, or mark on those triangles to show where those arcs are going to be similar. So if I didn't want to rewrite the entire triangle out, this angle and this angle are going to be the same thing. And I can find two triangles that use this angle. So G, E, and F. And then also F, H, and G. Those ones both use this point. And the little one is the only one that uses that one. So my similarity statement was this right down here. GFE is similar to FHE, is similar to GHF. All right, as I did this, which one helped you visualize it better? The highlighting or the angles? Okay, I'll highlight in the next one again, okay?
We have a question.
Yes, ma'am.
So you have 3 triangles, but I only see 2.
So I've got, here, we're gonna do blue, yellow, and then green, kinda. So my first triangle is gonna be this guy here. Triangle 1. Triangle 2 would be this one. And then triangle 3 is this giant one.
Oh, okay.
So we're starting with the giant triangle, and then we're just cutting it straight down the center with an altitude at 90 degrees. All right, I'm going to use those same highlighters. I'll go to my next shape here. Do you want me to redraw all 3 triangles, or do you want me to try to do, or show you how to do it just with this? Just with this, okay. I'll give you a chance to write it down, and I will show you how they are similar. All right. So let me get this little thing out. I know that if this one is a right angle, this one is also a right angle. Just kind of want to throw that out there. So the first thing I'm going to do when I look at these ones, I'm going to try to find the things that are completely opposite of my right angle. So this whole side over here, the big thing, that one's a hypotenuse. This one is a hypotenuse. And then the whole length for this one would be a hypotenuse. So if I'm going to go in that same kind of order, I know that LM, KM, and then the full length, they could be compared together. Okay, just so I can kind of be showing you what I'm doing. This angle here is the same as this angle over here. Okay, so I've already done the hypotenuse side. I'm going to measure the kind of the right angle that goes to that point. So the right angle to that point would be this one, would be this one, and then it'd also be this one. So it's kind of tricky when you're looking at them if you don't draw them out. So I'm going to do my comparison statement, my angle statement. But again, when we're drawing the same shapes, it gets kind of confusing if you're trying to put them all together as one. So I'll start with my big triangle. I've got M, L, K. I'm starting with my right angle, and then I'm going to my smaller arc, and I'm going to my no-name side. So I'll just write the steps I'm doing. I'm going from my right to my marked angle to my unmarked. Just showing you the order that I'm going through. So for the big triangle MLK, I went from my right angle to my marked angle to my unmarked. For my next smaller triangle, I'll start here. I'm going to start with angle P. I'm starting with my right angle. I'm going to my marked angle to my unmarked angle, which would be PMK. And then for my last one, so this triangle here, I'm going from my right angle, so P, to my marked angle L, to my unmarked angle M. Write yourself a little note if it helps. For me, I try to always do mine the exact same way. I'm always going to do mine right angle, marked angle, unmarked angle, just so that way I'm consistent every single time I do it. But as you can see, if I'm trying to mark down the corresponding sides, since they share a lot of the sides, it gets a little confusing. Like this one is sharing for two separate triangles. Oops. Okay, this one, I want you guys to try to do this one. I'll make it as big as I can. This one's off. This one actually. They're not right. I can't figure out which ones. If there's two that are the same. So yeah, mark that little angle that shows them similar. So you have the right angles now. I say mark this angle. This angle here. Which one's gonna have the exact same? Make a little arc. Which one have the same side? That side, yep. Perfect. So start like, I'd say the right angle to the arc to the no angle. Perfect. Pretty good. This one doesn't match up. Alright, okay. Would be right there. Which this side. So this one actually roll down. It's not true. So this D plus. Okay. There's a little arc up there.
I'll probably have to be it pretty
So
soon.
we'll start with the
Not
right
really.
angle. Are you looking at the big one?
Are you glad?
You'll show the right angle.
He's smiling.
The little arc.
Which
And you're
one?
going.
Wait, what was that?
Arc, yeah.
You heard me.
We're starting with the right angle.
So I don't think it did.
The arc.
We're still about it. Just also like Kansas said.
Wait,
So let's look at this triangle. You're using the T and the S. Which one is the right angle?
Your most has always been even. Never like.
30. Please start somewhere.
This is the arc.
I think.
Yep. This one, it's gonna be this triangle here. Perfect.
Yeah.
Oh, I saw.
I saw so.
And the last one, so I'm gonna start with this smaller triangle. Which one's the right angle? So I'm gonna have the rest of it. We're only looking at that. This little
Ricky,
triangle.
you better not mistake.
So we have S, C, T, and
No,
no.
no, mistake.
I don't know how to do it.
This,
No, we're gonna-
this whole arc is gonna be right. So hump.
Oh,
Start with T.
Orange or white. Okay, we'll let you go first, and we'll follow behind, okay?
Okay.
We'll see how that goes for you.
Yeah.
Have a nice summer. Yeah.
I did.
Alright, this one was tricky, because I'm kind of seeing some people were struggling on it. I'm gonna write down, I'm gonna use the little arcs as I put them on my sheet of paper.
Will we have homework today?
Yes, that was the plan.
Are we gonna have time to work on it?
There should be a little bit, because we're almost done at this point. Okay? So, just a reminder, this is also a right angle. This arc over here and this arc up here are going to be the same. So when I do mine, I go from my right angle, and I go to my arc, to my nothing. So my big one, I'm going to start with my right angle, so it would be S to Q to R. That's my big triangle. Okay, my next one, I'm gonna go for my medium-sized triangle. I'm gonna start with my right angle, so it's gonna be T. It's gonna go to the arc, Q, and then it's gonna go to the side that does not have an arc at all, so it'll be S. And then I've got my last one is gonna go from my T to my S to my R.
How do you know where to start? Like when you start listing the numbers or the letters.
I usually start with a right angle.
Does it matter?
It does not matter as long as you're consistent. So if you wanted to start with where you put the arc, and then go to the right angle and then to the no name, or you can go from the little arc to the nothing to the right angle, that's fine as long as you're going in the same order every single time. And just kind of make a little note for yourself to remind you, unless you want to draw all the triangles. That'll work as well.
How do you like go in the same order?
So like again, so when I say my same order, I put my key over here. I tell myself I'm going to start with my right angle, because every single one of these that you'll do will have a right angle. I'm going to start with my right angle, and then I'm going to go to the side that I drew my arc on. So like this little angle here, and this one will be the same. So it'll always be kind of this one, and then the other side of that altitude. And then the very last side, so like this side I didn't make any notes on, or this one I didn't make any notes on. And then once you can kind of figure out the order of them, so that same order that I was putting them in, that's when you can start to compare the different triangles. Okay, so getting the order down is going to be crucial to figuring out this next part. Okay. Yeah. All right, so I'm going to explain the theorems here. So if we can figure out the sides and how they match up with each other, if you can get the sides that are going to be similar, then you'll know which ones can compare to each other. So like this one, I've got this shape here. I've got a triangle ABC, okay? With this whole entire triangle, because of which sides are going to match up with each other. X and H, these ones will match up with each other because of rotating it down. And then same way, this one and this one, because they're both going to be that other side, they will be comparable to each other. So I'm going to do that same triangle just to show you what I'm talking about. So I had triangle ADC. So I had a right angle here. This would be like my small arc. This would be my small arc. So I know that triangle DCA is similar to DBC. That's my similarity statement, kind of doing the same thing that we did before. So the length of DC, this one here, is going to be similar to the length of DB. This one here. Next one, AD, these first and last. Those ones will be similar to the D and the C. These ones here. That's how they were able to get those same numbers, or the order of them. So we're comparing the hypotenuse to the other two sides. I know it's confusing to go and try to like visually see this stuff. That's why as long as you get a strong understanding of how those triangles will match up, it will make the rest of this easier. All right, I'm going to do a quick little audible. I'm going to have you guys work on your statements first. I'm just going to do the triangle part, and then we'll get on to the geometric mean theorem. But if you guys don't get the setting your triangles up equal to each other, it's going to make the rest of this tough. So I'm going to switch it up. We're going to do like 2 parts to the same assignment, but I'm just going to start right now and have you guys work this one. So it was on page I'm gonna go to right here. Page 541. Okay, I did want you to do 8 through 16. Even. Okay. Here's the deal. I'm giving you guys time in class right now. I want you to work on this, not to work on any other stuff. Do the 541, 8 through 16 even right now. I want to make sure you guys have it. Fingers crossed you won't have any homework, and I should be able to go on with like about 5 minutes just to explain the theorems. Okay?
What numbers?
8 through 16 even.